Okay, is everybody ready? Try this one.
So you're taking away. Oh, it'll be positive. It would be all good. It would be all taking away. Well, I think so. It's like we know that by memory. So how do you actually? I think what you have to do is you have to have them cancel out. So you have to have 6 yellow, right? So then when you take them away.
Somebody got it?
When you're taking away the negatives, you're left with the positives. Does that make sense? So why are you taking it away? Because you're taking away 2 groups of negatives.
I hope we all know the correct answer to this problem, right? But who has got a concrete representation of that? What have you got?
So we have the 2 groups of -3, which would give us 6 reds.
2 groups of -3, which would give you 6 reds.
Which are the negatives. And you want them to, because you're taking them away, you need to have corresponding ones, so you need yellow ones. So you need to have 6 yellow ones. So they're.
What do you mean? Because you're taking them away?
Because you're taking them away, so then when you take them away, you still need to have something there.
Why are you taking them away?
Because it says taking away 2 groups of -3. And so when you're taking away the 2 groups of -3, that's going to leave 6 yellows. It's kind of hard to explain.
If this one meant 3 piles of 5 yellows, right? And this one meant 4 piles of 3 reds, what would this mean?
2 negative piles.
-2 piles of
-30.
3 reds. The 3 reds I can handle. How do you build -2 piles?
You have to add neutrals.
Everyone who can build -2 pile, raise your hand -3 times.
You would have to add neutrals.
You understand the problem? Doing something a negative number of times is not possible. There are some limitations that come about with the chips when it comes to multiplication. We can handle a positive times a positive times a negative. We could even handle a negative times a positive if we commuted them and said, oh, 5 piles of 3 red. But this says -3 piles of 5 yellow. Do you understand what I'm saying? So negative times anything with chips is going to be difficult. Chips are not the answer to our multiplication, at least if we want to multiply positive times positive, positive times negative. Those are fine for chips, but negative times anything is very difficult. So what do we do? How do we teach? How do we teach?
I don't know if this is like too hard for them to understand, but like we can pull out the negative.
Pull out the negative. Is this?
Like, you know what I'm saying?
No.
So like on the negative 2 times negative 2, you'd be like
This one?
Yeah, negative and parentheses 2 times 3, and you just have to show that you have to distribute -1. You know what I'm
Oh.
saying?
She says take a -1 out, and that's
It'd be
2 times 3.
And then we'll just have to teach them like I just don't know if their minds will be both.
They'd have to understand the distributive property in order to see that. Thank you. Yes. If we did, then we could use the chips. I could make 5 piles of 3 red. Yeah. But the way it's written, I can't have -3 piles of anything. Yeah.
How come, like, okay, I know the distributive property, you can take out that -1, but -1 times 6 is -6, and -2 times -3 is +6.
2 times 3 is 6. times -1 is
-6.
-6. Is that correct?
That's not the right answer.
No. So what's wrong with that? Is that the distributive property?
No.
What does the distributive property say?
You have to distribute the -1 to the 2 and to the 3.
Well, negative, negative.
What?
Didn't I? Didn't we?
Isn't it the distributive property of addition?
Yes, distributive property says that multiplication distributes itself over addition, and this is not addition, so this is not true. Yep. Okay? Not true. Doesn't work. So what do we use?
We normally teach them that a negative times a negative makes it a positive.
That's something to just memorize. Right?
Right.
We're trying to make sense of it. Something that will make sense to them, and they'll say, oh, I see that and I understand that. But this is just something for them to memorize.
Can't we go back to like the stories that we used?
Tonight, we're going to go back to some stories. There's one other one I want to show you before we do that. And that is the number patterns that we went to. Are you ready? Let's go 2 times 3. What's that? 6. Start where with number patterns? The known. Somewhere where they're convinced that they understand. They understand this, right? And then we'll go. What will they say the answer is here? 4. 2. They're comfortable here. What should I write next, class? How are they going to know what to tell you to write? It's a pattern. What should I put here? 0. Now they'll know the answer to that, right? But how else could we get there besides the answer? What's happening here? It's going down 2 each time. What's next, class?
2 times -1.
What will the answer be? I don't know, teacher. We haven't done negatives. They'll know because it's what? Down 2. So what's it going to be?
-2.
Down 2. Down 2 more. Correct? And so on. Now, this doesn't say why, but it's a pattern that they're very confident here, and the pattern takes them into the unknown, which allows them to start to experience what's happening down here and have confidence that this is correct. Does that make sense? And then we ask questions. When do we have positive answers? And you do this not just with one pattern, you do it with a whole bunch of them around the room. And you'd ask, when do we get positive answers? Positive times a positive. When do we get 0? When we're timesing by 0. When do we get negative numbers? When one of our numbers is negative, right? And so on. Now, how would you teach a negative times a negative? You'd have to do a whole bunch of these positive times negative and convince them that the answer is negative, right? And then you could start off, if they knew that a positive times a negative was a negative, you could start off with something like 3 times, wait a second, negative, let's go -3 times 3. They'll know the answer to that once they've seen a bunch of these patterns. What will it be?
-9.
-9. And then you go -3 times 2, and they'll know it's -6. They've had to have done a whole bunch of these to do that. And what's going to happen here? We get -3. And now what? 0. And that's 0. And What are we doing here? Going up 3 higher each time, right? So what do we end up with? 3. Now tonight you'll get some other ways of looking at it, but number patterns are a way to go. This one has some assumptions that they know what a negative times a positive is. Okay? And what about division? How would you teach them division? Be thinking of that. We need to try one fraction before you leave, because I think they're going to, if we go 2/3 times 3/5, how do we do that? You all have a piece of grid paper. 2/3, what I would do is come down, 1, 2, 3, 1, 2, 3, 2/3. There's 3/3. Does everybody agree coming down? And I'm going to color in 2/3 out to here. Then if I go 1, 2, 3, 4, 5, there's, if this is fifths, 1, 2, 3, 4, 5, there's 5/5 or a whole, right? 1, and this is 1, 3/3. But I only want 3/5. So I'm going to color in 3 of those fifths. You see 1, 2, 3, 4, 5 of them? And I'm going to color 3/5. You with me? No? I've divided this into thirds, 1, 2, 3. And we have 2/3, so I colored in 2 of those thirds. This is fifths, so I divide it into 1, 2, 3, 4, 5 rows. And we're concerned with 3, so I'm going to color in 3 of those columns. How do I get my answer? Where it's double shaded, where there's overlap. Where is that? Right in here. What's my answer? 1, 2, 3, 4, 5, 6 of what? Well, if this is 1 and this is 1, then I have a 1 by 1, which is, here's my whole. And what's in there? There's 15 little squares, and I've colored in 6 of them. My answer must be 6/15. Does that make sense? Now, that can be reduced, correct? But inside the unit, the whole, the 1 by 1, there are 15 squares, and only 2 of them have double shading in them. So it's 2 out of the 15 is our answer.